Good day everyone, today we're going to talk about static determinacy of internally stable structures. But first, let us define what is internal stability. A structure is considered to be internally stable or rigid if it maintains its shape and remains a rigid body when detached from the supports. Sa kabilang banda, ang structure ay masasabing internally unstable o hindi rigid if it cannot maintain its shape and may undergo large displacements under small disturbances when not supported externally. Sa figure na ito, makikita ang mga forms ng rigid body at lahat ito ay kayang i-maintain ang shape under its loads. Ang figure na ito naman ay ang mga examples ng internally unstable structures. Makikita na ang mga structures na ito ay composed of two rigid parts, ang AB at BC na connected by hinge joint B, which cannot prevent the rotation of one part with respect to the other. So, tapos na natin i-define kung ano ang internally stable o rigid at internally unstable o non-rigid structures. Let us now proceed to static determinacy of internally unstable structures. Since ang plane na internally stable structure ay masasabi na ring plane rigid body, in order for it to be in equilibrium under a general system of coplanar loads, kailangan na supported ito ng at least tatlong reactions that satisfy the three equilibriums. Matapos natin i-define ang static determinacy or internally unstable structures, let us now proceed to the formulations for stability and determinacy of beams and frames. So, makikita natin sa figure and conditions ng determinacy, indeterminacy at instability ng beams at frames, where yung R is yung number of support reactions, ang C naman ay ang equations of condition o ang dalawang equations sa internal roller at isa sa internal pin, ang M naman ay number of members, at ang J ay ang joints. Makikita na kapag ang number of joints plus ang number of support reactions ay mas maliit kaysa sa number of joints, ito ay statically unstable. Kapag naman ang pinagsamang number of joints at number of support reactions ay equal sa number of joints, ito ay statically determinate. Kung ang pinagsamang number of joints at number of support ay mas malaki kaysa sa number of joints, ito naman ay statically indeterminate. So, meron tayong alternative formulation for determinacy and stability of beams and frames. Kapag yung R o yung number of support reactions ay inad sa number of reaction forces transmitted by an internal hinge or internal roller, ay mas maliit kesa sa number of members times 3, structure is statically unstable. Then, kapag yung R plus Fi is equal lang siya sa product ng 3 at number of members, structure is statically determinate. Kapag naman ang R plus Fi is greater than yung product ng 3 at number of members, structure daw is statically indeterminate. Para naman mahanap natin ang degree of indeterminacy, we will simply subtract yung sum ng R plus Fi sa product ng 3 times number of members. Since na-discuss na natin yung formula, we will now proceed sa practice problem. So in this problem, we will classify the beams shown as stable, determinate, or indeterminate at hahanapin din natin yung degree of indeterminacy. So, yung kagamitin nating equation ay R is equal to 7, M is equal to 2, C is equal to 0, and J is equal to 3. And as we multiply 3 sa 2, which is equal to 6, at i-add ito sa 7, which is equal to 13, at i-multiply ang 3 joints sa 3, makikita na ang number of support reactions at ang number of members ay mas higit kaysa sa number of joints. This concludes that ang beam natin is statically indeterminate. To determine the degree of indeterminacy, we will subtract 13 to 9 and we will have 4 degrees as a result. Using the alternative formulation for determinacy and stability of beams and frames, we have R is equal to 7, M is equal to 1, Fi is equal to 0, And applying the equation leads to 7 plus 0 is greater than 3 times 1 or 7 is greater than 3. Therefore, ang ating beam is statically indeterminate to the degree of 4. I believe that is all that we can learn about static determinacy of internally stable structures for today. Thank you for watching.